This line of code performs a simple but crucial task. Let's break it down. Require tidyverse. This function checks if the tidyverses package is already installed and available for use in your R session. This symbol represents a logical not. It reverses the result of require. So if tidyverse is not installed, require returns false, require becomes true. If it's a conditional statement, the code inside the if block executes only if the condition is true. In our case, if tidyverse is not installed, the condition becomes true. Install packages tidyverse. This command installs the tidyverses package. It runs only when the tidyverse package is not already installed. Automatic package installation. By using this command, we automate the process of checking for and installing tidyverses. If it's already installed, the script does nothing. If not, it installs the package for you. Why this approach? This method is efficient and user-friendly, especially in a learning environment. It ensures that everyone is on the same page with all necessary tools ready for use. Now, let's move forward in our tutorial by installing some key R packages that are pivotal for data visualization. These packages are recommended in our tutorial. I'll walk you through how to copy the necessary code snippets from the tutorial book. Then, I'll demonstrate how to paste them into RStudio, ensuring that everyone is comfortable with this process. Control plus Enter will run all code. Understanding assignment and addition. Let's explore some fundamental operations in R, starting with assignment and basic arithmetic. Using the assignment operator in R is used to assign values to variables. Example, x plus y. This will add the values of x and y, giving us the result 3. Working with sequences and vectors, R is particularly powerful when working with sequences and vectors. Example, x, 1, 10, a sequence from 1 to 10. Each element of from 1 to 10 multiplied by 2, x plus y. In this example, x is a sequence from 1 to 10. E is a vector where each element of the sequence 1, 10 is doubled. When we add x and y, R performs element y's addition. Introduction to functions in R. Functions are a cornerstone of programming in R, allowing you to encapsulate and reuse code efficiently. Let's create a simple function for addition. To define a function, we use the function keyword. Here, addF is our function name, and it takes 2 parameters, x and y. The function's task is to add these 2 parameters. Once defined, we can call this function with different arguments. This calls addF with 1 and 2 as inputs and will return 3. In this case, we're passing 2 sequences from 1 to 10. The function will add these sequences element-wise, returning a new sequence. Exploring sprint. The sprint function in R is used for string formatting. It allows you to format and combine strings and variables in specific formats. Basic usage of sprint: to concatenate a string with a variable, sprint %s_jinha im. This produces the string im_jinha. For formatting numbers, sprint %0.210 formats 10 with 2 decimal places. Sprint %0 f10 formats 10 with no decimal places. sprint %0. %10 formats 10 as a percentage. Creating a custom percentage function. We can create a function to format a number as a percentage. %f equals function x sprint %0, f % x 100, %f 0.5. Here, %f is a function that takes a number x, converts it to a percentage, and formats it as a string. For example, %f 0.5 will return 50%. How about following code? P-value equals function PR if PR 0.0010.001 else sprint %3 PR. The p-value function I provided is used to format p-values. It takes a p-value per as input and returns a formatted string either as below 0.001 or in the format %3f based on the value of p. If p is less than 0.001, it returns below 0.001, and if p is greater than or equal to 0.001, it returns the p-value formatted with 3 decimal places.